working as a project manager in the public sector as well, and also as a researcher in the university. So I may be aware of some of the challenges that you may face managing the IT infrastructure for people, for students and researchers. In fact, our job as solution architects and in general as AWS, as Werner Vogel said in the keynote, we are offering not only services in the sense of virtual machines, infrastructure, and so on, but also expertise in order for the organization, especially in the public sector, to benefit and accompany them in their journey to the cloud. Today we are going to talk about some innovation that AWS is driving in the research field and how AWS can help university and research institute to benefit from the flexibility and agility that the cloud can provide. And in fact, we are going to see some of the examples that we have worldwide, but especially here in Europe, in order to share the success that this organization obtained using the cloud computing. So I would like to talk to you about 3 drivers. The first one is, this work? Yeah, it is, okay. So is how AWS is helping people, so citizens or researchers, accessing the information and the tools that organizations make available for them in the internet. So managers usually in the old world faced the problem when designing an application or an infrastructure, in the sense that they had a decision to make. Should I invest and create my infrastructure in order to be able, for example, to serve the average of my user base? Or should I invest for the peak? So if I invest for the average user base, the problem is that when a peak actually happens, the user experience may degrade because the web application may become unresponsive, for example. On the other hand, I can design my infrastructure to be able to serve the peak, but this also comes with a problem, which is how accurate we are with our prediction and estimates. And in any way, there is a problem, which is a massive expenses that comes with designing for the peak when our systems are underutilized. So AWS comes into an help in this, in the sense that you can adapt your infrastructure to the actual demand. So when there is a peak, actually you can follow the peak, and when there is no peak, but you can take out instances, for example, or resources, and be more cost effective. So a real example in use cases is UCAS. UCAS stands for the University and College Admission Service, and their aim is to help students throughout their entire higher education application process in the UK. So UCAS is part of the critical infrastructure in UK, because if UCAS is not able to process the application for students, there is no other way in which people can be actually successfully matched to the various university places. So there is one day, once a year in mid-August, when the E-level results are released, in which the UCAS website sees a massive peak of usage as users try to log in and enroll in the various universities. So to give you some numbers, in the morning of that very day in mid-August, they face something like 200 logins per second, too much for the system to cope with. In fact, in 2011 and in 2012, they suffered from age availability issues and capacity problems. So instead of investing in their own internal infrastructure, in 2012, they decided to move into the cloud and used AWS in order to be able to serve the peak of mid-August and then scale back when the emergency was over during the rest of the year. From the technology point of view, UCAS uses of AWS services ranging from Elastic Compute Cloud, AC2, which serve as the foundation, as the baseline for the web application and websites, with auto-scaling, which is a feature that allows you to create policies and adequate, as I said, the amount of resources that you need in real time. They used also elastic load balancing to route the traffic among the instances, and VPC, the virtual private cloud, for the networking capabilities. But they also took advantage of something which is called infrastructure by code, which gives you the ability to script your own infrastructure in a JSON code and treat it as a source code, so you can deploy infrastructure using CloudFormation and take advantage of the ability and the agility of deploying this kind of infrastructure. With that, UCAS was able to reach a goal, which is now to serve 400,000 students, scaling 15 times their average capacity for just effectively 1 day. The other driver is increasing innovation, and probably this one is the one that I love most, because it gives the ability and the possibility of experimenting fast in a new cloud environment. So researchers or organizations can test new stacks, new application stacks, run their experiment very quickly, adopting AWS. Also gives something like a democracy in the computing power, in the sense that even small laboratories now, or small research groups, as well as big organizations, they can take advantage of a massive computation capacity that lays behind with AWS. So an example is Novartis. So the Novartis Biomedical Institute research is the division in Novartis that study how to cure certain kind of diseases, like, for example, in the oncology field or cardiovascular. So the usual time for a drug to come to the market is 10 years, and it costs something like $1 billion. So in order to reduce those times, Novartis take advantage of what is called HPC, high processing computing. With HPC, what they can do is perform virtual screening, simulations, image analysis. So in 2013, they wanted to run a project and screening against a common cancer 10 million compounds. So they calculated that for making this experimentation with their internal system, they needed something like 50,000 cores for this project. They needed something like 40 million, more or less, dollars, sorry, and 39 years of computational chemistry. So in order to use their internal system for this project, they, together with a partner called Cycle Computing, they used AWS, leveraging 4 availability zones and spot instances, reaching something like 87,000 cores, and made this experimentation. So they were able to reduce 39 of computational chemistry in just 9 hours, spending only more or less 4K, which compared to the 44 millions is impressive. But actually what impressed me most is that out of 10 million compounds that they were screening, they were able to find 3 candidates for curing a disease, a cancer, in just 9 hours. This is impressive, and this is what we meant when we say that AWS reduced the time to science and helped to increase innovation. So we mentioned spot instances. What are spot instances? Basically, the spot instances make you give you the possibility to name the price of what you want to pay for a specific instance type. So you go to the console and you say, for example, that you would like to run this specific instance, and you would like to spend maximum this price. So basically, you are bidding to the spare EC2 capacity. And if the price that you named is above the current spot price market, you get the instance. So with that kind of infrastructure, research institute, they can use a great and very large computing infrastructure while reducing also the cost. So for example, what they do is that they can create a cluster using on-demand instances for the project A, which is the main important, for example, but also using spot instances to increase the computing capacity in the cluster and run maybe another project B in order to reduce the times. So with cost effective, they can run 2 projects sometimes at a time. Another important tool is the AWS Marketplace. So Marketplace is an online store where you can find application, probably application that you are already familiar with, that are able already to run into the AWS platform. So you can go to the online marketplace and select, for example, the tools that you are already using and deploying it in your AWS environment. So in a few clicks, actually, you can get ready and get results from your experimentation, reducing the time to science because you don't have to spend time procuring a new infrastructure or installing and configuring the software. It's already there in the marketplace. And the marketplace is not only for research institutes, of course. You can find plenty of softwares, like, for example, networking softwares, firewalls, and so on. The last driver is collaboration. And when it comes to collaboration, it's very important the meaning of universities. So university comes from the word universal, which means everything. So the ability to share, it was a common place to share ideas. So I think that sharing is a very important key point for education and university. And we are in the world where we are talking about, for example, open data, big data, or tools to enhance the ability to make research. And AWS actually is a perfect platform for this. For example, you have tools like S3, simple storage services, that gives you the ability to store unlimited capacity, a limited amount of data, paying only for what you actually use, with a high durable environment, up to 11 nines of durability. Or there are tools like EMR, Elastic MapReduce, that then can use to elaborate the big data or the massive amount of data that you store on S3. And an example of this is the European Space Agency. So the European Space Agency is an organization, you probably already know it, with 20 organizations and 20 members all around Europe. And their aim is to continue to invest in space and verify that these investments continue to bring benefits to Europe and the whole world. So within all the projects that they have in the ESA, they also run a project called DUE, Data User Elements. And the aim of DUE is to demonstrate the usefulness of Earth observation objects. So basically, the DUE program collects data from the satellites all around the Earth and transfer those data as objects and make those data available to users and research worldwide. And this data is used for a myriad of purposes, like, for example, to increase the accuracy of weather forecasting, or for agency, for relief agency when there is a crisis or a disaster. And AWS helped ESA in this project, serving the images and the objects in S3, and also with EC2 for the statistical analysis. And what I actually like most about this example is what they say. They said that AWS is so simple to use that they can manage the systems by themselves and the service by themselves, which again is the aim that we have to reduce the time to science for the organization and research institutes. And with that, I hand to our friends from the Heidelberg University.